So first I'm gonna close this finished part, and I'm gonna start a new one. So the idea here is to start from this base of this bracket, and we will go up until we finish this part. So I'm gonna start sketching on this extrude. I'm gonna start extrude boss, and I'm gonna start sketching on the top line. I'm gonna make center line. I'm gonna make 2 circles. So the first circle is this represent this curve, which has a radius of, let's say, 22 millimeters. Now the diameter will be multiplied by 2, and this other circle, which has a radius of 40 millimeters, so its diameter will be 40 times 2. Now the distance between the first circle and the third circle here, which is the same as the first one, is 100 millimeters. So the distance between these two circles will be half of 100 millimeters. I'm gonna make tangent lines. Gonna mirror this line about this center line. Then I'm gonna trim, choosing trim to closest to, actually before trimming, gonna make another center line here. I'm gonna mirror this circle and these two lines about this vertical center line. I'm gonna trim the overlapping curves of those circles. Now our base is almost complete. Gonna exit the sketch. I'm gonna extrude this base about, as you can see here, 18 millimeters. And check OK. And now I'm gonna make these 2 holes for the bolts. So I'm gonna start sketching on this base. Gonna choose a circle. And the diameter of this hole is 15 millimeters. I'm gonna mirror this circle, but first I'm gonna make this vertical center line. Choose it as to mirror about it. Now it's ready. I'm gonna go to extruded cut, and I'm gonna choose through all. So now the base is complete, and now we're gonna make another plane which is at the center of this base. So I'm gonna go to references and geometry and choose plane. So the first reference will be the right plane, and the distance is gonna be 0. Now we have a plane to sketch on. Now I'm gonna make this line, which is 67 millimeters. I'm gonna give it a dimension of 67 millimeters, and I'm gonna add a point here so that I can make a relation between the line and the point. This relation will be coincident. Now I'm gonna make another center line starting from the ground up until we reach this distance, which is 76. Now we can draw the two circles, the inner one and the outer one. So the inner circle will be 30 millimeters. The outer circle will be 46 millimeters. I'm gonna make two lines that are tangent. Now we can see this icon that indicates that this relation is tangent. In case of, let's say I delete this relation and try to move this line away from this outer circle, and if I want to add the relation between this circle and this line and this circle, I can do it using this tangent relation. I'm gonna trim this extra portion of this line. I'm gonna mirror this line about this center line. Now our sketch is ready. I'm gonna extrude part of the sketch. I'm gonna go to selected contours and select my regions. I'm gonna choose these two regions. I'm gonna change the direction 1 to a middle plane, and the thickness will be 80 millimeters as it is here. I'm gonna check merge result, and now the first part of this bracket is ready. I'm gonna make the sketch shown so that we can extrude the other part of it. So I'm gonna select the sketch, and I'm gonna go to contours, selected contours. I'm gonna choose this part of this sketch. Now the thickness here is gonna be 46 millimeters. I'm gonna click OK. Now we have. I'm gonna hide this plane as well. Now we have our bracket almost ready. I'm gonna add some fillets to it. So here the fillets are they have a radius of 3 millimeters. I'm gonna change this radius to be 3 millimeters, and I'm gonna select this face and this face. I'm gonna click OK. I'm gonna make another fillet, selecting this edge. Make sure to select this tangent propagation. Now the part is this model is complete. Now all what we have left to do is just to make a simulation for it. So I'm gonna go to, let's say, add-ins. Gonna click on the simulation, or I'm gonna check it. Now it will take some seconds to start up, and now we can see that its tab is it's here. I'm gonna click on it. I'm gonna go to new study, and now we have multiple studies. So I'm gonna choose static, and the name of it I'm gonna leave it as it is. I'm gonna click OK. Now, first thing to do is to go to this part and right click on it and apply a material so that we can make this simulation. So for this study, I'm gonna choose alloy steel, click on apply and then close. You can see that the color has changed. That indicates that the material of this bracket, which is a large seal, was applied to it, and we can see that the material name is here. I'm gonna go to fixtures and I'm gonna choose fixed geometry. So where I want to fix this part, I want to fix it at this place and this place that represent the bolts places. I'm gonna go to external loads. I'm gonna choose pressure. Here I'm gonna choose this face to apply the pressure on, and for the units I'm gonna choose Newton. Newton for every meter square, which means Pascal. I'm gonna give it 100,000 Pascal or Newton for every square meters. I'm gonna click OK, and by the way, you have to click normal to selected face, so it can be normal. I'm gonna apply a mesh for it, so I'm gonna right click on it and create mesh. Now these settings are okay for the study, but if you want to go deeper in this mesh settings, so you can go to mesh parameters, and you can go also to advanced settings. So I'm gonna click OK. Now we will see that this mesh was applied correctly. Now we can see those, let's say, mesh or nodes of this mesh that represent the points where the stresses or the study will be conducted. So now the settings for this static study is ready. I'm going to go to run this study, click on it. Now it will start solving, and we can see this bar indication that indicates the progress of the study. Now we can see that it has finished, and we have 3 results. Stress 1, which is chooses 1 misses, and we have displacement and strain. So we can see that yield strength here is 6.2 multiplied by 10 to the power of 8, and the maximum stress here is 2.4 multiplied by 10 to the power of 6. That means we are below this yield strength by a lot, I think, and this is safe for this load. But to check whether if this is safe or not, we're gonna go to results and right click on it and go to define factor of safety. So now we have some settings to choose from. So here I'm gonna go to maximum 1 misses stress. I'm gonna go to next, click on next. Here I'm gonna choose the units. So, and the stresses stress limit. So I'm gonna choose yield strength, since I want to make this study so that when this material start changing, not breaking, so it will break if we the ultimate strength is used to test whether this part will break or not, or this material break or not. But yield strength when the material start to deform. So I'm gonna go to next, and here we can select whether we want to the factor of safety to be distributed along this part, or if we want the areas below factor of safety. And here we should specify the minimum factor of safety. So here we have the safety result, and it is here it says minimum factor of safety, which is 257.9, which is more than we want, which is 1. So I think it's okay. I'm gonna click on OK. Now we can see the distribution of this factor of safety. So most of it, I think it's in red color. That means it's about 2 and 2.5 and maybe 2.6 multiplied by 10 to the strength of 2, or to the power of 2, sorry. Now we have the factor of safety, but if we want to get the reaction at where we fixed or where the bolts will be, so I'm gonna go to results and go to list result force. So here I'm gonna choose reaction force, and here I'm gonna select where I want to calculate this reaction forces. I'm gonna choose this hole and this hole. So here you can see that we don't have results, but if I click on update, we can see that we have the fx, which represent the force on the x-axis and on y-axis and on z-axis, and we have here the resultant of all these forces at this point. We also have these results of this reaction forces at this point also. So if we go down or scroll down, we can see that we can get the report options here, and we can save it to let's say a CSV file if we want, which is an Excel file, or we can copy it to clipboard if we want. So now it's okay for this study. So this is the end of this video. You saw how to model this simple part, which is a bracket, and how to use these dimensions to model this bracket. And we have also made a simulation to check whether will it withstand this load that is 100,000 Pascal or Newton for every meter square. So this is the end of this video. I hope that you have enjoyed it, and I will see you in the next one. Thanks for watching.